Hi, good morning, everyone. So yesterday we have discussed the remainder theorem, and basically it says that when we have a polynomial, it can be quadratic function or cubic function or even higher. And when we divide the polynomial by a linear term, x minus c, it will give us the remainder, and it is just simply the value of function of c. So I'll give you an example using the quadratic function that we had yesterday. So for example, we have a function of x equal x squared minus 3x plus 2, and you see, when you divide this fx by, for example, x plus 1, so basically we divide this quadratic term by a linear term x plus 1, what happens is you will get another function. So in this case, you see, if you have a quadratic, you divide by linear, you will have a linear term here. Now, you will have a remainder. Now, the thing is, when we just want to get the value of the remainder, we can just plug in the value of f of c. So in this case, you need to be careful now when you divide by x plus c. So this is your x minus c, right? So when you divide by x plus 1, in this case, this is your x minus c, yes? So your minus c here equal to 1. Therefore, the value of c here is minus 1. So now we are finding f of minus 1, where what you want to do here is just simply insert that number into this expression, this function. So minus 1 squared minus 3 times minus 1 plus 2. So what we will get, we will have, 1 plus 3 plus 2. So this gives us a remainder, in this case 6. But when you divide the polynomial divided by linear term, the remainder is not always giving us a number. Sometimes they will give us, another linear term. Well, basically it depends on this function fx. So we will look at another example of this one. Now, you see, the second part of a theorem that we have here is called vector theorem, and this is also very important. So basically the vector theorem says if you have a polynomial fx and it has a vector of this linear term, so the linear term x minus c is a vector of fx, that happens if and only if when the remainder, or this value f of c equal to 0, or in other words, when x minus c is a vector of the polynomial, that happens when the remainder, f of c is 0. So, well, we already find the factor actually of this quadratic function. You see, remember when we have x squared minus 3x plus 2, and then you try to find the solution of this quadratic expression. So basically we equate this to 0, and then we got the first one is equal to 1, and then the second one equal to 2. So now from this one we get x minus 1, and then from this one we get x minus 2. So basically, I can write down x squared minus 3x plus 2 as x minus 1 times x minus 2. So, you know, this is actually just to factorize x squared minus 3x plus 2 into two linear terms like this one. Now, as you know, when x minus 1 is a vector of the fx, that means when you plug in now f of 1, this value, when you put that 1 here, 1 minus 1, which is 0, and then you multiply it by something, so basically what you will get is 0. And also when you have x minus 2 is a factor of that fx, then the same thing also happens where the value of function f of 2 is also 0. So this is actually a very important idea, especially when you want to see if a linear term is a factor of a polynomial or not. So basically you just plug in a value, and if the function gives us 0, that means that linear term is the factor of the polynomial we have here. So actually the example that I want to give you now, it is something higher than a quadratic expression. So let me give you now a bit higher. For example, we have, instead of quadratic function, we have now a cubic. So cubic function is simply a function that has a power of 3. That's the highest power in the cubic function. Now, you know what happens is when we have a polynomial, so like this one, we try to, normally we'll try to factorize this polynomial. And what happens is when we factorize the polynomial, we can have the factors to be the linear terms, like what we had before. Or, you know, sometimes when we factorize a polynomial, they can give us also linear times a quadratic. So it depends on what we get here, okay? But there is one important thing when you are trying to make, you know, the factor, when you are trying to get the factor. So we have to make some guesses. And the way we do some guessing is just actually when we have a polynomial like this, and then you see the coefficient in front of x cubed here already 1. And then the next thing that you want to look at is simply this last value, the constant, the number. So with this number, we need to find out all of the combination of the product that can give us this number. For example, 1 and 6, and then 2 and 3. So you see when you multiply 1 times 6, you get 6, and then when you multiply 2 times 3, you get 6, and then when you can have also, of course, minus 2 and minus 3, or minus 1 and minus 6. So the guessing that we will do here basically based on these values. So it's not you know, any values actually. It's not random number that you want to put into that fx. So the value that you want to put in is just from this combination, from these possibilities. Yeah. Now let me give you, for example, if I have these possibilities, let me start from the first one here. this value 1. So how do we know if this one is the solution of this polynomial? So basically, when you remember with the factor theorem, now when you put this function of 1, so let's see what we got here. And this gives us 0, which is something that we are looking for. Now when you get 0 like this one, that means x equal to 1 is the solution of, x cubed minus 7x plus 6 equal to 0. Or when you now move this number to the left hand side, x minus 1, yeah, equal to 0. So now you are looking at this term. So that x minus 1, yeah, is a factor of x cubed minus 7x plus 6. This is important because when you're trying to put different value, for example, now let me give you an example with this number minus 1, and let's see what we get. So let's try with f of minus 1 now. Yeah, when you put this minus 1 and then put into this function, and see, we get minus 1 and then plus 7 and then plus 6, and that gives you non-zero value, which is 12. So if that's the case, what happens is the value x minus 1 is not the solution. Or now when you put this minus 1 to the left hand side, yeah, we get x plus 1 is not the factor of x cubed minus 7x plus 6. So that's actually how to see whether a value, a number is a factor of a polynomial or not. You can simply put these possibilities into fx and remember how to get these possibilities. When you look at this number, you just find out all of the combination of the product that give you this number. Yeah, for example, 1, 6, 2, 3, minus 2, minus 3, and so on. And then when you plug in those values, see which one give you 0, because those number give us the solution, or this x minus 1 is the factor. Now, the thing is, we need to find out also some other factors, because if you have a cubic function like this one, normally you would expect to have 3 solutions. Yeah, remember when we have the quadratic function, we will expect to have 2 solutions. Now we will expect to have 3 solutions. So when you want to get the other solution, of course, now we look at the factor that we already have here, x minus 1, and then we now need to do the long division of this divided by x minus 1, and this is something that I want to show you here actually, because this is very important. Yeah, when you have x cubed minus 7x plus 6, and then you want to get the other factors of this one other than x minus 1, so what you do is to do the long division, x cubed minus 7x plus 6, and the way we do this is something like what we did before. So first we divide x cubed divided by x, and that gives you x squared, right? Now what you do with this x squared, you will multiply to this guy and also this guy. Okay, but I'll move this a bit further, so I'll just move this a bit here. Now, when you multiply the x squared to x and then minus 1, you will get x cubed and then minus x squared. Now what you do with this, you want to subtract because you want to get rid of this x cubed, right? So now we'll just have this guy 0. So basically this is 0 and then minus x squared. This gives us x squared, and then this guy minus 7x minus 0, that's simply minus 7x. Okay, so at the moment you don't need to pull this number down. Yeah, just leave it like this, x squared minus 7x at the moment. And now we'll do the same thing. Basically we'll divide x squared by x, and that gives you x. And now what you will do with this x, you just do the same thing again. You know, you multiply with x and minus 1 so that you will get x squared minus x, and then you subtract again because you want to get rid of x squared here. So now minus 7x minus x, that gives you minus 6x, and now you pull this guy down plus 6. So again, we will divide one more time. So minus 6x divided by x, that gives you minus 6. And then when you multiply this number to x and then minus 1, you will get minus 6x plus 6. So, you know, the nice thing about long division here, that also give you the remainder, of course, because this is just a number that you get at the end of your long division, which is 0. Not only that, because when you do the long division, basically what you get here is the answer. So basically, you know, when you are dividing x cubed minus 7x plus 6 divided by x minus 1, this is something that I told you in the beginning. This will give you something. Yeah, in this case, it's a quadratic, and then plus the remainder. In this case, it's 0. Yeah, so of course, this is slightly different from the quadratic function that we had before, because when you divide a quadratic with linear term, that will give you a linear, but this one you have a cubic and then you divide by a linear term that will give you a quadratic. So basically, I can write down the x cubed minus 7x plus 6 here equal to you know, the product of x minus 1 times x squared plus x minus 6. So look at this now. You can factorize your cubic into a linear and then a quadratic, yeah? So now I'll just copy this first, yeah? So basically I want to have this now. And then let me move to this here. So again, you know, when you have this cubic, I can now factorize it into a linear term and also a quadratic, yeah? And this is nice because now what you want to find is the other solution where we will need to now get the solution for this quadratic term. And the way to do that, you can simply use the quadratic formula, or you can factorize it. So in this case, we will get, you know, x, and this one is 3, and then 2, and then this one is plus, and then this one is minus. Yeah, because you see, this is actually quite nice number, and if you look at the combination, this will give you minus 2 and plus 3 here. So you see basically that x cubed minus 7x plus 6 can be factorized into x minus 1 times x minus 2 times x plus 3, and all of them actually will give you the solution, where the solution of the first one is just 1, and then the second one is when x minus 2 equal to 0 or x equal to 2, and then the third one is when x plus 3 equal to 0. So basically the last one is just minus 3. So this is just an idea, give you how to get the roots or solution of a polynomial where we are using something so-called factor theorem. Yeah, and I guess we need to understand this very well because we will use this very often in the future. So I think that's for today, and I'll see you again next time. Thank you.